Let's derive the formula of an equilateral triangle. Because I know in an equilateral triangle, I know all the sides are the same length. And then when I draw in the height, which will be my apothem here, my height, I'm not going to put h there because I know it's a 30, 60, 90 triangle when I draw in my height. And so I know the base of this triangle is 1/2 x. And then I multiply it by the square root of 3 for my 60-degree angle. So the square root of 3 times 1/2 x is my height. So I know the area is base times height divided by 2. Well, the base of my entire triangle, notice that's x, isn't it? So I'm going to say x times my height, which is the square root of 3, times 1/2 x. Well, let's simplify that. Oh, I almost forgot. I got to divide that by 2, don't I? So my numerator is the square root of 3 times x squared. And I'm going to take 1/2 of 1/2, which is over 4. So the formula for the area of any regular triangle, when I know the side length, I'm going to take the square root of 3 over 4 times the side squared. We're going to use that quite often because that's one that shows up quite a bit. Now, let's see if we can derive the formula for any polygon, not just a triangle. So I know if I look at this hexagon, and it could be any shape, to find the area, I'm going to find the area of the triangle. That'll be 1/2 times the base times the apothem. I'm going to call the actually side length, if that's okay. So I know it's the side length times the apothem, and then I multiply it by the number of sides. Well, what's important here is to understand if I take the side length and I multiply it by the number of sides, like in this case, if I take 3 times 6 sides, I'm finding the perimeter, aren't I? So a lot of times we'll write this as 1/2 AP. So 1/2 the apothem times the perimeter. And that's the formula you see in your study guide over on page 3. Now I want to find the area of a regular hexagon in this shape. So what I have to do is I have to go back and I have to find the apothem, got to find this and the perimeter. So I know the formula is 1/2 A equals 1/2 AP. Well, in this case, I know P is 5, right? No, I don't know P is 5. The side length is 5. So I know the side length is 5. And since it's a hexagon, I know each side is 5. Oh, it's an equilateral triangle here. So you know what I think I'm going to do? I'm going to use my formula for equilateral triangle because I know the side length. So I know it's the square root of 3 over 4 times 5 squared. That'll be the area of my triangle. Then I'm going to multiply it by 6 because there are 6 sides. So I'm not going to use the apothem per se on this one. I'll use that maybe in a different one. If you have a hexagon, when you have an equilateral triangle, because your central angle is 60 degrees, that works out pretty darn nice. So in other words, I get, 25 times 6. Well, let me see. 4 and 6 can be reduced, so I'm going to say that's 3 and 2. So I take 25 times 3, so I get 75 times the square root of 3 divided by 2. That'll be the exact area. We'll say square meters. And there's your answer. Now, what happens if it's not a hexagon? It's a pentagon. Or in this case, notice on example 4, they didn't give me the side length or the apothem. So what do? Well, this is where everything comes back into play. So I know the formula is A equals 1/2 AP. So I need to solve for A and P. So A is the height of my triangle. Notice. Now in this case, it's a pentagon. So my central angle is going to be 360 divided by 5. Did Didn't I just do that? 360 divided by 5. So my central angle is 72 degrees. But I'm not really interested in the central angle. I'm going to draw in, since it's an isosceles triangle, I'm going to draw in the height, which is also the angle bisector. So this is 36 degrees. And I know my hypotenuse is 9. So then I can find my height, which I'll call A. I don't know why I put H there. Let's call that A for Apothem. Well, that's adjacent and hypotenuse. So I'm going to say, oh, the cosine of 36 degrees equals the adjacent A over the hypotenuse, which is 9. In other words, the exact answer for A is 9 times the cosine of 36. Which, if I use my calculator, I'll take 9 times the cosine of 36. And I get 7.2812. So A is 7.2812, about. Now I want to find my side length. But my side length, I'm not really going to find the side length because I'm using just my right triangle here. So what I'm going to do is I'm going to find half of my side length. I'm going to call this x. Well then, opposite hypotenuse, I'm going to use sine. So I'm going to say, oh, the sine of 36 degrees then is x over 9. Or x would be 9 times the sine of 36. So if I take 9 times the sine of 36, use our calculator there. So 9 times the sine of 36, that is 5.2901. Now, since I know x is half the side length, I know my whole side length, I just take that times 2. And I get 10.5801. And then to find the perimeter, I'm going to take that times 5 because there are 5 sides. So I multiply this by 5. And I get 52.9007. Now I can plug in my formula. 1/2 AP. So the area of this pentagon is going to be 1/2 times my apothem, which is 7.2812, times my perimeter, which is 52.9007. And then we'll round that. I think I'm going to round to the nearest whole number because my radius was rounded to the nearest whole number. So my area, we're going to say, is about, if I take 0.5 times 7.2812 times 52.90, which in this case on my calculator is my answer. And I'll round that to the nearest whole number and say, oh, that's about 193 square centimeters. Notice on this one, we found the area without knowing the apothem or the side length. We're just given the radius. So each time you're doing a problem, you're probably going to be given some different information, and we want to use that information to solve the problem. But everything comes back to 1/2 AP.